Good morning, everyone. The topic that we are going to discuss today is the inventory management. We have three forms of the inventory. I think you have already been taught about this kind of or this form of inventory. The first form we call it raw material. Raw material is the object, commodities, elements, or item that you are receiving from outside organization. For instance, suppose we are talking about McDonald's. The raw material may come from the market or come from their supplier. And this raw material will be used directly in the production of the final product. For instance, the example of the raw material like a sheet metal, flour, chemical, engine, or integrated circuit. And then once the raw material get used into the process, being used in the process, the first step in the process, the status of the raw material become work in process. Okay, starting from the first process until the end of the operation. After it passed all operation that the process are required. So the status of the inventory will change into finished good or the complete product. So maybe the finished good, maybe the noodle or the burger or something like that. Okay, so this is the form, three different form of the raw material, of the material or of the inventory. So for the inventory management, we need to answer two questions. The first one is, when should an item be placed to replenish the inventory? Okay, when we should place order, and at that time, how much should be ordered, right, for that item. So we need to give the answer of these two questions. So we got three different type of inventory management system, and for this lesson we are going to focus just only on the first two, that is the reorder point system, the first one here, and the periodic review system. Okay, for this one, material requirement planning, we are going to talk in next week. So this is the example that we explain you about these two policy. Suppose we are the distributor of the bottled water. We sell around 1,000 bottles per month, and assume that the demand is constant throughout the year. And we use policy of ordering 2,000 bottles per order. And we assume that instantaneous replenishment, meaning that whenever the inventory level reach zero, we place order and that order will come to our stock immediately. Right? Okay, this is the example. This is the picture to represent the inventory level. So the y-axis represent inventory level in our stock, and x-axis represent time. This is because we use month, so the time is in month, the first month, second month, third, fourth, so on and so forth. At the beginning, okay, coming back here, every time we order 2,000. So first we order 2,000, and that order amount come immediately to our stock. So in our stock we got 2,000, right? And it says that this company sells 1,000 per month. So after the first month, the inventory level reduced to 1,000, right? Okay, here is 1000. And then after the second month pass, okay, at the beginning of the second month or the second month pass, right? Okay, so sorry, after the second month pass, the inventory will be reduced to 0 because this month will need 1000 to fulfill the requirement of the customer. So once it's reduced to 0, and our assumption is that we assume instantaneous replenishment. So in that case, we place order here, right? And then we get the inventory or we get the item immediately. So the stock in our company will increase immediately to 2000 here. And then again, customer require 1000 per month. So at the end of month 3, the inventory will be reduced to 1000 again, and month 4, at the end of month 4, inventory will be reduced to 0. And then again, we press order here, right? And it's come to 2000 again. So this is the picture to show the inventory level with respect to time. Okay? So the first policy of the inventory management system is the reorder point. Normally we will press, okay, if we assume that instantaneous replenishment assumption, so we press the order whenever the stock reduced to 0. But in reality, okay, in reality we cannot do that because we got the lead time, right? Lead time is the production lead time. So we need some times before the item will come to our place after we place the order. So in this case, you can see that here, okay? The inventory reduced to 0 here. If we place order here, right? Because they need some times after we place the order until the order come to our company. So if we place here, so we have to wait until here before the inventory will go up. Okay, so during this time, our stock will run out and the customer may not be happy. So we have to place the order before the lead time. So if this is the lead time, okay, this is the lead time, this is time unit, and then we need to place the order here, right? We need to place the order here. So the item in the inventory that equal to the number of lead time will be the reorder point. Okay, this is the inventory level. So we call this one as the reorder point, right? So for the reorder point policy, whenever the stock item reduce and touch this point, so we have to place the order, and that order, okay, and that order will be equal to this amount, okay, and the item in our stock before the inventory, the replenishment comes, we call it reorder point here. So the reorder point normally established so that the inventory on hand meaning that inventory that you have got it in your stock, okay, physical inventory that you have in your stock, is sufficient to meet the demand during the lead time. This is the purchasing lead time, right? Okay, so we got one of the system that is very popular in the reorder point system. We call it two-bin system. Okay, so we divided the stock into two bins, the big bin and the small bin, like this one. Okay, we got these two bins, small bin, big bin. Whenever we fill in the stock, we fill in the small bin first and then big bin. Okay, fill. And then when we use the item from the big bin, and whenever the big bin finish, that is going to be the reorder point. We press the order, and this amount will be equal, the amount in the small bin will be equal to the reorder point. Okay, for instance, suppose we look at the inventory level here and the time here. So at the beginning we have two bin, big bin and small bin. Okay, so the big bin is about this size, okay, is about this much, and the small bin is about this much, right? Okay, so first we fill in the big bin, we fill in the small bin, the item in the small bin, and then the big bin. So, and then we use the big bin first, okay, the item in the big bin we use first, and then whenever it touch, or whenever the big bin is empty, we press the order. Okay, we press the order here, and then because we know that there will be some lead time here, okay, we need to wait until that time, and then the inventory level will go up after the lead time come here. And the item in the small bin here, we call it reorder point. So suppose I can give you some example. Okay, suppose every time we order 27 unit. Okay, the EOQ or economic order quantity is 27 unit. Whenever we order 27 unit, and average demand is 3 unit per day. Order lead time is 2 days. If we use reorder point, especially for the two bin system, how many units should be placed in the big bin and the small bin, and when will the inventory be ordered? Look at this picture. Okay, so every time we press order, we order for 27 unit here. 27 unit is going to the amount of the big bin and small bin. And the question says that the average demand is 3 unit per day. So you can see that at the moment you got 27 unit on hand. You need 9 days to finish this inventory, because 27 divided by 3, right? 27 divided by 3, you got 9 days here. And if there is no lead time, so you press order at day 9, but there is the lead time, that is purchasing lead time or ordering lead time of 2 days. So you cannot wait until day 9. So you need to back it, okay, to day 7, because it needs 2 days. Day 7, 2 days. 9 minus 2 is 7. This day you press order, and this order will be equal to how many? 6. 6 come from every day you need 3 unit, okay, and this 2 day, okay, this 2 day. So 3 multiplied by 2, you got 6 unit, and 6 unit become the reorder point here, this one. Okay, the lead time, the unit of lead time is day, but the unit of the reorder point is the amount or the number of the item that you are required to use during the lead time. Or sometimes the reorder point, we may call it demand during the ordering lead time, because your lead time is 2 days and demand is 3 days. So the demand during the ordering lead time will be 6 unit, right? 6 unit. So this is the reorder point. So according to this picture, whenever the stock come to finish, okay, before that Okay, so you know that you got 27 here, and you know that the small bin is 6. You put 6 here. So 27 minus 6 is 21. This is the big bin, the amount in the big bin. So the big bin has 21, okay, and the small bin has 6 unit or 6 item. And then once the item comes to your store, the inventory will jump to 27 again, because every time you order 27, right? And then after 9 days pass, okay, 9 plus 9 is 18. Then you cannot order at the day 18. You need to order 2 days before, right? So you need to order at day 16, and then the amount before you order, that is the reorder point, is 6, right? Okay, so this is the reorder point. So you don't have to count the day, but you're just looking at the big bin and small bin. So you can see that whenever you use the big bin first, right? You use from this one first, and then once the big bin finish, you press order, right? Press order, and then you press order. How much do you press? 27, okay? And then the picture will be like this again. So this is the reorder point system. Another system that we may use, okay, for the not so important item, so we don't have to constantly monitor the item. So actually we use the periodic review system. So every equal time or every equal interval, like every month, every quarter, every 6 months, we just count the inventory in our store, and then according to the number, we place the order. So for the periodic review system, the reorder quantity is going to be the maximum inventory level that you are required minus on-hand inventory. On-hand inventory is the inventory that you already have in your store. On order quantity, meaning that sometimes you place order and that order has not yet come to your store, okay, that is on order, okay, and the demand during the purchasing lead time, right? Okay, this is the formula that you have to use in the periodic review system. Suppose, okay, this one, 2 bin, big bin, sorry. Suppose you switch from the reorder point to the periodic review system. So how often should it be reviewed? Okay, that is time. The cycle time is going to be 9 days, right? At this, okay, 9 days. Every 9 days you just monitor. And again, if there are 2 units on hand, 10 units on order, what is going to be the reorder quantity? According to our formula here, okay, the reorder point is equal to the maximum inventory minus on-hand inventory minus on-order inventory plus demand during lead time. So the maximum inventory, we got 27. On-hand, we got 2 here, okay, and on order is 10, right? And demand during lead time is going to be 6. We got it here, or the reorder point, demand during the reorder lead time, 6 reorder point here, okay. So the item for that we need to order, reorder quantity for the periodic review system is going to be 21 units, okay. Now we are going to discuss about the EOQ, or the economic order quantity, that will give you the lowest cost of the order. The assumption is the constant rate of demand shortage are not allowed. Stock replenishment can be scheduled to arrive exactly when the inventory drops to zero. Purchase price, ordering cost, and per unit holding cost are independent of the quantity order. Items are ordered independently of each other. The notation that we are going to use in order to calculate the EOQ is Q is the order quantity, U is the annual usage rate, and CO is order cost per order. CH is annual holding cost per unit. Don't forget that everything has to be converted to annual usage, okay, to annual, okay, holding cost and usage, right? So here, suppose your Q, okay, Q, whenever you order 2,000 bottle, okay, it's not EOQ, this is just your choice to order 2,000. Every time you use 10,000, so the usage rate is equal to 12,000 bottle per year. And if CO, okay, is equal to 60 and CH is equal to 10, the picture is going to be like this. The maximum inventory level is 2,000. The demand, okay, usage rate is 1,000. So every month, okay, after 1 month pass, the inventory will be reduced to 1,000 and finish after 2 months finish, right? Okay, and this one is the average inventory or maximum inventory. Average inventory is equal to maximum inventory divided by 2, right? Okay, maximum inventory divided by 2. So we got the average inventory level. Here, the average inventory level is 1,000, 2 months finish. Now we need to find the total cost. Total cost will come from 2 components. The first one is annual ordering cost. This Q is the amount that we order every time, and this axis represent cost. So if we order in a small amount, okay, in 1 year, how many times that you need to order? You have demand per year is U, okay, and whenever you order Q. So the frequency of order per year is U divided by Q, and every time you have to pay CO. This is the total cost that you have to pay. If Q is small, meaning that you have large number of ordering per year, so the cost will be a lot. And if the Q reduce, okay, if Q reduce, the cost will be reduced. So the graph for the annual ordering cost will be like this. And the graph for the inventory holding cost, annual inventory holding cost will be like this. This is the Q divided by 2 is going to be like a average inventory, okay. Q is your maximum inventory. This one, this Q, okay. Q divided by 2 is the average inventory. Multiplied by CH. If the average inventory is Q divided by 2, okay, and the inventory holding cost is CH. So if Q is increased, the cost will be increased. So if we sum these two costs, this one will be the summation of these two costs, that is annual ordering cost and annual holding cost, okay. We sum these two costs, we get the total annual cost. The graph for the total annual cost will be like this, and there will be 1 point, okay, 1 point that gives you minimum total annual cost. That point we call it EOQ, economic order quantity, meaning that if you order exactly the same as EOQ amount, your total annual cost for inventory will be minimum, right? Okay. This is the formula. This is the formula for the total annual cost. This one is the holding cost. This one is holding cost, and this one is ordering cost. You plus these two together, we get it. We get the total annual cost, and if we differentiate and make it equal to 0 and rearrange the equation, so you get EOQ as square root of 2 multiplied by U multiplied by CO and divided by CH. Okay, so according to our example, okay, the demand per year, okay, is 12,000, and CH is 10, CO is 60. So EOQ is equal to square root of 2 multiplied by 12,000 multiplied by 60 and divided by 10. We got this amount. And the average inventory level, we have EOQ divided by 2. That is going to be 189.8 item. Okay. And total annual cost according to this formula, total annual cost according to this formula, that is the Q will be substituted by EOQ, that is this amount, okay, 379.6 divided by 2 multiplied by CH, CH is 10 plus U is 12,000 divided by Q, Q is again 379.6 and multiply by CO, CO is 60. So the total annual cost, the lowest total annual cost, we got this amount. Okay, quite simple. So if you want to draw the picture, okay, whenever you order 379 item, and then we need to find this point. Okay, the day that the inventory will be reduced to 0. You can use the rule of 3 in arithmetic, in mathematics. You got 12,000 butter, you need 365 days, but here is 379.6 butter. How many days? Okay, you got 11.5 days here. So you draw this graph, and because we assume that 2-day purchasing lead time, so you cannot order on the 11.5 day. You have to order at 9.5, and the demand during the lead time. Okay, you want to find the demand during the lead time. That is the reorder point. You use the formula like 365 day, U is equal to, for the 365 day, U is equal to 12,000 bottle, but here is 2 days. How many bottle? 65.7 bottle. You got it here. So this is going to be the reorder point. And for the reorder point, the amount in the reorder point is going to be equal to the small bin. And the amount in the big bin, okay, for the amount in the big bin is equal to 379.6 minus 65.7 is equal to 313.9 item in your big bin. Okay? Hope you understand. And here is your assignment. I give you the annual demand of 24,000, and if CH is equal to 15, CO equal to 50, lead time is just 1 day. Find EOQ, TAC, draw the inventory picture, find the reorder point, and item in small bin and big bin if the reorder point is used, and if we change the reorder point for the if we change into the periodic review system. PR stands for periodic review system. If on hand inventory is 20 and on order is 10, okay, what is the reorder quantity of the PR? Thank you. See you next week.